Hello, hello everyone. Today we are talking about the computer vision. So, computer vision is the field of artificial intelligence. Okay, that enables computer to interpret and understand the information coming from the world, similar to how we human understand the images like objects, persons, buildings, and cars. There is a short definition we are going to discuss, which is a very informal definition. We may not find any exact definition anywhere, but we are going to informal definition. We're going to see the informal definition right now. So, computer vision is a branch of AI that trains computer to interpret and make decisions based on visual data from images, videos, and other visual inputs. So, what we are going to do is when we see the object. So, what if we are capturing just image? That is not an image. That is just image acquisition. Uh, but when we are trying to understand what is inside that images, for example, we are trying to identify what is the object. Is that a mug? Is that a person sitting there, or is this a chair, or is there any building? What is the context of that image going to which kind of categories? So whenever going, we are trying to understand the image, and we have got some insight from the image, then that is called the vision. So basically nowadays there are a lot of progress happened in this field. So where we can apply use this computer vision. Computer vision we can apply for image recognition. Image recognition, there are several tasks we can come under this category. So identifying the objects, people, scene. So even we can see the context of image. Where, for example, we're talking about the image of uh, building, or image of a cities, image of uh, flowers, or image of animals, dogs, something like that. So this is the image recognition. Object detection. Object detection is like whenever we see objects like a chair, mug, laptop, mouse, charger, mobile, mug, this kind of objects. So these are all objects. So several objects in day-to-day life we are going to see. We have to identify several objects, so even identifies the object, right? So same way we can make computers to enable to understand those objects, right? And facial recognition. So how we are going to see, we can understand one person from another. He's my teacher, he's my X, Y, Z. So we can see the persons, right? So this is how we recognize the persons by seeing their face and other aspects, right? Okay. There is one more thing comes into picture, right? Optical character recognition. So this is sometimes very crucial because sometimes you want to uh, convert ancient documents into a digital format, right? So here we have a scanner, and we have the image captured of it. So sometimes we take a snapshot from our mobile, so that is there, but how to process the data in between? So we have to recognize those characters from the digital image. So so from that we can convert the textual data, and we can further process that data. To do that, we need to understand what is the characters written in that particular image. So this is one of the important use case of computer vision. So in uh, medical imaging, uh, in medical imaging, we see the MRI images, X-ray images, uh, and CT scan images, sonographic images. So these kind of images are there. We day to day life of a medical professional, you can see they have to encounter these kind of images. From that those images they have to get the insights whether particular person is suffering for particular disease, or there is a bone fracture or not. So those kind of analysis usually person do. The same thing we want to do by using machines. So in these fields also we use a computer vision. So there is a third chapter, next use case, we can say that is autonomous vehicles. So autonomous vehicles are like uh, nowadays it is a boom market now. Now you can see there are ADAS levels are coming into pictures, like ADAS level 1, level 2, level 3. So so in this thing, there are several type of data sensors are there in our cars nowadays. For example, radar is there, sonar is there, and also cameras are there. So we have to uh, analyze the data and make a decisions like a driver, the persons. And once we do that, we can able to drive the vehicle. So this is what the computer vision is all about. So if you see the computer vision, there's a, to do that, what is important is the image. So what we have to understand what is the image, and what is the videos. Videos are like a set of images coming one after another in several interval of time. Okay, these are the videos. So what is the image? We have to understand first. What is the image? An image and a visual representation of something. It can take various forms such as two-dimensional image. Two-dimensional image which contains drawing, painting, photographs, digital graphics. So these are two-dimensional images. And three-dimensional also images are there, sculptures and carvings. So it's we can see there is digital three-dimensional form, digital pictures, and optical mirror reflection, and these are the images we can see. So here what is important when we deal with the computer vision is a uh, digital image. So because whatever the digital cameras are acquiring the images, those are sent to the processor in the digital format. So digital representation is a visual object such as photograph seen in the digital format. It is compressed in a tiny elements called pixels, each with the specific numeric values that represents its intensity of color. What are those color? Usually these are RGB colors. Okay, R means red, G means green, B means blue. RGB colors. Uh, then this is the format actually usually this is very standard we can think of. There is one library in computer vision, that is OpenCV, which stands for uh, open source library for computer vision. So they use BGR format instead of RGB. In later videos we may see on it. Okay, so in digital image, these pixels are arranged in the grid of rows and columns, uh, for forming a complete image. Okay, so a digital image can be created using various devices like digital cameras, scanners, when synthesized from the mathematical functions. If you see uh, mathematical functions, like there are graphs are generated, those kind of also images are there. So those images are like mathematically produced synthesized images. So these are there. So in the later course we may see how to synthesize the images and all. So typically they are stored in the formats JPEG, PNG, and TIFF format. So as we some of us might know, JPEG is very good. It has a very good compression ratio. So reducing the file size very small as compared to original one. PNG is basically used to keep all the information intact and all. So this is the PNG format. TIFF format is also there. So these are the technologies. So anyway, we have to use one of those format for our particular problem. So we have to now let's go to some of the code. We see the images and we how those images are generated. There are two important libraries we are going to import from the Python. So one is NumPy. Uh, NumPy is like if we are dealing with the matrix and all, matrix and arrays of the numbers, then we have to use. It is a very friendly to use NumPy. Uh, and to plot those arrays, we are using matplotlib library. Okay. Now you can see this is the array of images. For example, this is 0 to 55, 0 to 55, 200, 100. This is the array. This is the two-dimensional array we can see here. And let's see how this works. Oh, so sorry, I have not imported this one. Now this will work. Now this is the image store. Now we can see how that array looks like. Now you can see this is the NumPy array showing all those information in it. Now let's try to plot this. Now here you can see 0 means completely dark image, black side. 255 means bright, and again black. Again 255 is a white. 200 is somewhere in between to white to black one. That would be a shade of a gray. Again a black, and these are some other shade of gray we can see here. Okay. This is the color map. Now you can see here I have used a color map as a gray, but now let's see here. Now you can see you cannot see just a gray scale, but some colored images. It is a yellow and purple and some different color of images. So this is the default scale. This is plotting on a default scale of PLT, matplotlib. What is that scale? I have just created one array to see those images. Let's run this. In gray, you can see this is running from white to a direct, completely dark images, like a completely bright to black image. Okay. Uh, Now let us see without this gray what will happen. Now you can see. So where 255 values is there, it is like a completely yellow, and this is like a you can see it completely purple color, something different color. Uh, so now this is the two-dimensional image. Now in general, you can see digital image has a three channels. What I have already said to you, these are like RGB channels. Now we are going to see those here. Now how it looks. Let's go and add one more cell and show you. Now you can see these are the three-dimensional arrays. This is three-dimensional array, but two-dimensional image. At a third dimension, you can see the channels. This is the first channel. This is the second channel. This is the third channel. In digital images, the first channel can be referred as zero index. Second one is a one, and third one is a two. So this is how array look like. Now let us see on standard uh, standard plot. You can see this is somewhat looks like a color, a shade from this color bands. But now you can see those are having a green, blue, uh, yellow, black, those kind of colors. Now you can see here at last pixel, this is the black one. To make it a black, what we have, uh, what what are the values it has taken. Now this is the first red, this is the green, and this is the blue. Uh, okay, now this becomes a black completely, 0 0 and 0. That should be a black, right? Now let us see on grayscale. Here also you can see the same image. Wait, no. We can do a same thing with another scale. Now what is that scale is a 0 to 1 rather than 0 to 255. Let's do that. Again we see AMG. Yeah, you can again see the similar. Now it is converted to floating points. Now again plot this one. This will also look similar. Okay. Now we can access each pixels from the image. Now let's try to access. Now this is the image, and we can see the data types. What is the data type? Data type is a float 64. Now, sometimes we have to convert those data type from float 64 to float 64 to float 32. How to do that? This is the simple command we can see here. Now here also you can see the same image. Nothing has changed us too much, but the image look like same. But here you can see the type of that image. Now it is a numpy of float 32. Now again see the image which has the values 100, same values, but the type, earlier it was a float 64, now it is a float 32. We can assign the values to the pixels, right? Now here you can see the image. Now I have assigned the value to the pixels as a 1, pixel 0 0 0. Let's see how it works, where it goes. It becomes 1 means I have just given the value uh, to the image 1. Now let's see here. uh, we can also do something like that. The 2 to 1, we have again assigned the value 1. Here you can see uh, 2 to 2. Let's go to second row, which was earlier like a 1 1 1 1 0 0, right? 1 0 0 1 1 1 0 0. Now like here 0 1 0 1 0 1 1 0 1.5 1. Now here 1.51. Now 0 0 1 0 1 1 1 0 0 0 0 1 0 1 1 1 0 0. So this is how we can assign the values. Now you can see the image. Oh, it looks quite similar to that. We can also plot the partial image, right? Like here. Now what I have did is I have uh, plotted a second channel, right? Second channel. How? This is the second row. This is the 0 1 and 2. This is the second row I have plotted here. We can also do same thing, but now it is one first layer, the along the first channel. You can see here. Can again do something like this. This is like a zero first index, at the zeroth index of all the images. You can see first index, second index image. Now we can see what is at the first index. Okay, we can again plot it in grayscale. You can see same thing in grayscale also. We can also see images something like this, 2 and 2 to all, something like that. You can see the same array over here. So now there are two different way to see the same thing. Here also we can see 2 to colon means it start from 2 and takes all the values above, to start from 2 and take all the values above. There are several ways to do one thing. Now here you can see what is the value at that pixel, 222 index value. What is that value? That is completely dark. That is a 0 value. You can see this is color map, and we can see we can even take only few pixels, like 2 pixels we have taken out. We can see uh, at a zeroth level what is the values are there. Now 0 1 0 0 0 0, where we can see that here 1 0 0 0, right? Correct. Now come back. Now let's make our hands dirty on actual images. What are those? I have taken my own image, and there is one more image of a tree. Let's see what is that. This is how one of my image it look like, and this is one more image. Now here you can see this is a sea. It is a very beautiful tree. I have captured one more wall. Okay. Uh, so how I am reading the image? plt.imread. This is the function I am using to read the images. Okay. Now you can see these are the JPEG images. Okay. Now next we can also read the PNG images. Just we need to change the extension. It would be the, and it is also looks quite similar here. Okay, I have also taken this image for later purposes, and let's see what are the values are there. Now here you can see there are in image value. What is the image? Image is this. Image is a PNG image. In PNG image, you can see there are four values: 1, 2, 3, and 4. So these are the four values, and PH image 2 is a JPEG value. Here you can see uh, uh, the pixel values. Here you got 243, 243, 243. Okay, these are also same values, but there is a one channel you can see here that is called a transparency. That is called the transparency. You can see usually JPEG images are 3 channel images, but PNG images are 4 channel images. That's why their size is also more. That is not a only reason, but that is one of the reason why PNGs are have a larger size than a JPEG. Now again, I do see another image. Same way here also you can see shape of the image. Shape of the image is there is slight change. You can see uh, here you can see the 3 channels ex uh, ex see this is the vertical axis, this is the horizontal axis, and this is the third axis. That is third axis is the channel number of channels. Now here you can see these first two axes are the same, but fourth axis is has length change in it. Now it has 4 channels, not 3 channels. Here you can see the same image, and again We can crop those image like this also. We can select some part of the image and we can see those images like this also. And once we crop this, we can also save this image. Okay, we can save this image in desired folder, whatever you want. Now jm crop png is there. I have stored somewhere. Okay, we can do several operations like rotation, flip, this kind of operation also we can do. Now this is rot 90. So rot 90 degree. Uh, okay, this is the counterclockwise. This has rotated this image. You can see this image. The right corner is now upper, lower right corner is now upper right corner. You can see here. Now rot 90 minus 1. If you see, you can see this is, we see minus 1, we put a minus 1, this will again come back to original position. Okay, let's try this one. Now flip one, flip upside down. Now image is flipped upside down. We can also do left to right, the same image from uh, left to right. This is the left one, left part is came to right and right part come to left. No, we can also do twice. If we do twice rotation by 90 degree by twice, we can do. See, this is one rotation that would be a vertical image, and the second rotation now again we got we return to the original image. Now we can see what is the average intensity throughout the image. So this is 144. 114 is the average intensity. Again, we can see the shape. Now, here you can see. Now, at the third channel, we can take a part of image, the zero channel we have taken, and we can also see its shape. Now, there is a Python command called zeros, np.zeros xy. So, what I have taken is one image, uh, our image, and I have taken one channel of it, and I have took out the values, xy values of it. Okay, those are here. Now, what we want, I want to generate one image which has the values zeros, all the values zeros. Okay, and what I do is then np.zeros and xy. So those parameters I have fed into it. So this is how the arrays are generated. All the values are 0, 0, 0, 0 here. You can see what is the type of array? It is a numpy array. Now we can use this uh, uh, array to generate our next images. Where we are using now, we have RGB image. We want to convert to a grayscale image. So for that purpose, I have wrote a function, and I can use here the same strategy I am going to use here. Now, what is my strategy here is, now I want to take rows and column values, shape of the column. So from the color image, it will be taking a color image in it. So the values is there, but we have actually taken here. This is the playground I have used before doing uh, actual function, before writing the actual function. Okay, so here you can see I have again created uh, image, what is called a G image. That is I'm referring to grayscale image, np of zeros and row column values to that. Now there is an image which has a value 0000 in it, so of the size of original image. What is the image we are going to fit in? Now there is a two for loops we are going to use here. We are running over rows and column, and we are actually, what we are doing, this is the first method we can do uh, by averaging this. Okay, now let's take average of the image values. What are the three values are there? For example, in this image, here we can see, let me go up there. Here you can see at 0 0 we have these three values. So we have to take to generate a grayscale image. We are now going to take average values of it, and we are going to generate the image out of it. Okay, grayscale. It's grayscale representation we are referring to. Okay, let's run this, and we have that function. Uh, Now let's use that function to our image. Okay, it's taking quite a while. So it has taken a hold time of 2.2 seconds. So now it is converted our image to RGB to grayscale image. Okay, now let's see the shape. Now you can see the same shape what actual image has. Now it has taken some time. But whenever now just we are taking dealing with a just a single image, and it has taken 2 seconds of time. When we are dealing with for example thousands of images or millions of images, in that case this time will multiply, and it will be a very huge time, and that we cannot handle. So n see this NumPy has a very good feature that can parallelize this process of multiplication of arrays. So let's try this. Now we can see here uh, what is the vaulting. It is like a 23 milliseconds. The same thing, everything is done uh, within a 23 minute, whatever the earlier result is. Yeah, earlier it took 2 seconds, but now it has taken 23 milliseconds. Okay, 23 milliseconds. Now here also you can see CPU time is 2 seconds, and here you can see the CPU time is 15.6 milliseconds. Now let us uh, do that value. That would be around 2 seconds. 2 seconds is like, it would be 2000 2000 milliseconds. Let's convert that, and something 15. Let be 15, and here you can see 130 times faster. It is quite faster as compared to previous one. That is np dot doing this. This is the function I have used to do this. Now there is one more thing we can do. One more method we have to do using the dot product. Here you can see this is also taken a similar time to process. We are actually basically doing the same thing, but two different methods. Here we have taken npy sum method, and here we have taken np dot sum, np dot method. Now here you can see uh, in dot product we have uh, the values which are exceeding 255. Because we have just used the plt function, that's why we don't see that value. Okay, uh, that's why but in this case it won't be like this. In earlier case that won't be such a bigger value. uh, it would be restricted to 0 to 255, but here is not that case. To restrict those value from 0 to 255, we have to again divide it by 1 by 3, 1 by 3, uh, all the pixels. Let's do that. It also takes similar time, but now here you can see NP max, it is the maximum value is 0 to 255. This is the white pixels. Now we can process further. Now again, we have we just reread our image. Yeah, okay. So we have already processed a lot of things. That's why I want to forget everything and want to take images. Now, how to take out those channels? Now, these are the RGB channels. To take out RGB channels, you can see what we can do is we just multiply 100, 010, 001. So from this, we are just keeping the first channel and the second channel and the third channel, we are making it zeros uh, and the same process, right? Let's do that. Okay, now let's plot this one. Now, this is the red image, this is the green image, and this is the blue image. Okay, uh, there is a difference. You can see uh, what is it should be the white part of the image that should be white in all the image. Okay, this is the white shirt. Everywhere you can see this is the white. Okay, uh, now let's see red channel. Where is red? Red. This flag looks like a red. One side of red, not exactly red. So you can see that part is a bright. In green, here it is a dark one, and blue also it is a dark. What does that mean is there is no red pixels here. Okay. Again, you can see the yellow here. Yellow is bright at red and green. So the yellow is a color is generated using these two pixels. You can see. Okay, but it is invisible in the third picture where blue channel is not used to generate uh, yellow color. Similarly, the green color you can see here also. Here you can see the green color is the darkest one. Why? Because no red pixel is used to generate the blue color. Now, there are several ways to process the images. We can also generate. No, till now, what we have did is we have converted uh, RGB image to color image. Now, let's try to convert RGB image to black and white image. Right? This is uh, our black and white image. So, where from grayscale image, I'm going to convert to black image. Considering what is the threshold? Threshold is a 100, 0 to 255 is the range we have taken. Let's do here. Let's change the threshold. What is the threshold? Now it is a 25. Now you can see all the images are bright. What it doing? What actually it is this function is doing is uh, all the values which are above 25, those are labeled to 255, and below are labeled to 0. That is that is why this image is brighter than previous one. There are other, let's try another threshold. This is the threshold we can tune. We can use tune and choose various thresholds and convert our black and grayscale image to black and white image. So this is the small summary and you can say the introduction about the images and all. So in the next videos, we are going to see several methods and the libraries to check out the images, and we will be seeing many other methods in the computer vision. Thank you very much. Subscribe to my channel.